Hello and welcome. My name is Jonathan Logston, and I will be giving you all a presentation on an IT technology that most people have heard about but probably know next to nothing about. I'm happy to discuss this little known technology, Internet Protocol version 6, and I will try to keep it interesting. This will be our agenda for the day. We will discuss IP network addressing, classical IP addressing, techniques to reduce address shortage in IPv4, the features of IPv6, header comparisons, extension headers, and conclusions. After this presentation, it is my hope that you will all have a clear understanding of IPv6 and its capabilities. No doubt you've heard the term IP address. Unless you're a techie, though, you may not have more than a shadowy notion of what an IP address actually is or how it works. An IP address is a fascinating product of modern computer technology designed to allow one computer or other device to communicate with another via the internet. In the same sense that someone needs your mailing address to send you a letter, a remote computer needs your IP address to communicate with your computer. We all know what the internet is. It has infiltrated every facet of our lives in 2017. But did you know that it doubles in size every 9 months? Did you also know that every device that connects to the internet, or any network for that matter, is assigned an IP address? Traditionally, what you are probably familiar with is IPv4. IPv4 is the predecessor to IPv6 and is still used for the most part over IPv6. Now remember when I said that every device that connects to a network gets its own personal IP address? Well, there's a finite number of them: 4,294,967,296 IPv4s out there for us to use. So although it hasn't happened yet, we will eventually run out of IPv4 addresses to use. That is the reason why IPv6 was created. The source address is the sender, the destination address is the receiver, and the subnet mask is what determines what traffic is sent and to whom. During the process of delivering an IP datagram, only the destination IP address is significant. When IP was first created way back in 1981, each system that was attached to the internet had to be assigned a unique 32-bit address. This scheme involved a two-level hierarchy: a network number and a host number. Classical addressing makes it possible to determine the network portion of the IP addresses by looking for the first 4 bits of the first octet in an IP address. The first 4 bits are referred to as the most significant bits of the first octet and are used to determine what class of IP address is being used. The value of the first 4 bits determines the range of actual numerical values of the first octet of the IP addresses in that class. The different classes of IP addresses, class A through E, were created to allow for carving up the entire set of all IP addresses into chunks of different sizes that would fit the number of hosts on the network for which the IP address space was being supplied. Most often, a class C address was supplied to anyone requesting space, as few networks had more than 256 hosts. But the networks grew to more than 256 hosts and needed more space, so class B addresses were given out. But if a network has only 500 hosts, and you assign a Class B IP address block to that network, 65,034 addresses will go unused. This is a terribly inefficient use of space, and as networks grew larger, the internet grew. The need to use the IP address space more and more efficiently became ever more critical. As the list of available IP addresses was depleted, it became clear that a new solution was needed that provided more addresses, and efforts turned towards developing what is called IPv6. The strategy used to partition a single physical network into more than one smaller logical subnetworks, or subnets. Classless interdomain routing, or CIDR, is a set of Internet Protocol IP standards that is used to create unique identifiers for networks and individual devices. The IP addresses allows particular information packets to be sent to specific computers. Shortly after the introduction of CIDR, technicians found it difficult to track and label IP addresses, so a notation system was developed to make the process more efficient and standardized. One solution that was created to reduce utilization of IP addresses was network address translation. As IPv6 is developed and implemented, NAT is a good short-term solution to the IP address shortage problem. Network address translation allows a single device, such as a router, to act as an agent between the internet or public network and a local or private network. This means that only a single unique IP address is required to represent an entire group of computers. NAT has many forms and can work in different ways. And a host segment. Subnets are designed by accepting bits from the IP address's host part and using these bits to assign a number of smaller subnetworks inside the original network. Subnetting allows an organization to add subnetworks without the need to acquire a new network number via the Internet Service Provider. Subnetting helps to reduce the network traffic and conceals network complexity. Subnetting is essential when a single network number has to be allocated over numerous segments of a local area network. Subnets were initially designed for solving the shortage of IP addresses over the Internet. Here is a detailed example of how subnetting works. As you can see, all traffic is filtered through the gateway, as represented by the red G. The gateway creates two subnetworks, 128.10.1.0 and 128.10.2.0. In each subnet are two hosts, H1 and H2 are on the top subnet, and H3 and H4 are on the bottom subnet. CIDR IP addresses consist of two groups of numbers, which are also referred to as groups of bits. The most important of these groups is the network address, and it is used to identify a network or a subnet. The lesser of the bit groups is the host identifier. The host identifier is used to determine which host or device on the network should receive incoming information packets, in contrast to classical routing, which categorizes addresses into one of three blocks. CIDR allows for blocks of IP addresses to be allocated to Internet service providers. The blocks are then split up and assigned to the provider's customers. NAT is like the receptionist in a large office. Let's say you have left instructions with the receptionist not to forward any calls to you unless you request it. Later on, you call a potential client, leave a message for that client to call you back. You tell the receptionist that you're expecting a call from this client and to put her through. The client calls the main number to your office, which is the only number the client knows. When the client tells the receptionist that she's looking for you, the receptionist checks a lookup table that matches your name with your extension. The receptionist knows that you requested this call and therefore forwards the caller to your extension. Developed by Cisco, network address translation is used by a device, firewall, router, or computer that sits between an internal network and the rest of the world. NAT has many forms and can work in several ways. Static NAT is mapping an unregistered IP address to a registered IP address on a one-to-one basis, particularly useful when a device needs to be accessible from outside the network. Dynamic NAT is mapping an unregistered IP address to a registered IP address from a group of registered IP addresses. Overloading is a form of dynamic NAT that maps multiple unregistered IP addresses to a single registered IP address by using different ports. This is also known as port address translation, or PAT, single address NAT, or port level multiplexed NAT. Overlapping is when the IP addresses used on your internal network are registered IP addresses in use on another network. The router must maintain a lookup table of these addresses so that it can intercept them and replace them with registered unique IP addresses. IPv6 offers a larger space for the address, better hierarchy, it's more efficient and easier to use in datagrams. It's much more efficient in terms of security, much harder for a hacker to guess what it is, and it's much faster. IPv6 uses 128 bits with 8 group of 16-bit hexadecimal numbers. Sounds like a lot, right? Well, it would be, but you can remove all the zeros in an IPv6 address, simplifying it like the example above. Isn't math just great? Routing concepts remain the same in the case of IPv6, but almost all routing protocols have been redefined accordingly. Fragmentation has been a frequent source of security vulnerabilities in IPv4, and for good reason. Unlike IPv4, IPsec security is mandated in the IPv6 protocol specification, allowing IPv6 packet authentication and/or payload encryption via the extension headers. However, IPsec is not automatically implemented. It must be configured and used with security key exchange. Encapsulation offers a way for IPv4 and IPv6 to coexist. Usually this means taking IPv6 packets and encapsulating them in IPv4 packets. Hop by hop simply puts a limit on how many networks, subnets, or subnetworks a packet is allowed to hop or travel before it is discarded. And similarly, destination options headers work by having the destination nodes read the header only. IPv6 header is much simpler than IPv4 header. The size of the IPv6 header is much bigger than the IPv4 header because of the IPv6 address size. IPv4 addresses are 32-bit binary numbers, and IPv6 addresses are 128-bit binary numbers. In the IPv4 header, the source and destination IPv4 addresses are of course 32 bits. And in the IPv6 header, the source and destination of the IPv6 addresses or 128-bit binary numbers. Needless to say, IPv6 is a great improvement to its IPv4 predecessor. Internet Control Message Protocol version 6 is an upgraded implementation of ICMP to accommodate IPv6 requirements. The protocol is used for diagnostic functions, error and information message, statistical purposes. Dynamic Host Configuration Protocol version 6 is an implementation of DHCP. IPv6 enabled hosts do not require any DHCP version 6 server to acquire IP address, as they can be auto-configured. There has been no new version of DNS, but it is now equipped with extensions to provide support for querying IPv6 addresses. A new Quad A record has been added to reply IPv6 query messages. Now the DNS can reply with both IPv versions 4 and 6 without any change in the query format. IPv4 fragmentation showed the potential to cause many problems. IPv6 fragmentation has slightly improved. Although there are still possibilities for catastrophe, most people don't even know IPv6 can be configured. Authentication header provides connectionless integrity, data origin authentication, and protection against replay attacks. It authenticates with an integrity check value, or ICV, calculated over the payload, the header and unchanging fields of the IPv6 header and options. Authentication header does not provide privacy and confidentiality of packet contents. Stateless auto-configuration is an important feature offered by the IPv6 protocol. It allows the various devices attached to an IPv6 network to connect to the internet using the stateless auto-configuration without requiring any intermediate IP support in the form of dynamic host configuration protocol. In conclusion, IPv6 is new. It's built on the experiences learned from IPv4. It has new features, it has large address space, it has a new efficient header, and it has auto configuration. However, it's also old and it's still using Internet Protocol. It's built on a solid base started by IPv4. It started in 1995, and it has a lot of implementations and tests done to it. These are my references. Any questions? And thank you.